And today we start talking about areas of regular polygons and circles. Our objective today, we're going to develop and apply the formulas for areas of circles and regular polygons. If you got to pause it to get that in there, pause it. It does ask you a question. It says use a ruler and measure the base and height of the triangle in centimeters to find the area of the triangle. And then asks, is there a process we can use to find the area of the regular hexagon? Alright, so there's my triangle. I drew in the altitude. I drew in the height of the triangle. It was 2 inches across here. Now I went ahead and I filled this in on my hexagon. And the thing that we need to know about a regular hexagon is I can always split it up into 6 equilateral, equiangular triangles. There they are. So I drew in all my diagonals, and I now have that shape, which I don't know if you can see. I'm going to go back. Notice the triangle here. This triangle here is the same as each one of these triangles. And the height of this triangle, the altitude of this triangle, is this altitude here. It's got a different name in a second. We'll call it something else. But that's what we need to be thinking about. So if I can get the area of this triangle, all I got to do is multiply that by 6. And that'll give me the area of this hexagon. And that's kind of what we're going to do here in a second. Alright, so let's do some definitions, and I'll keep going back up there in a second. So this is a picture right here. A regular polygon has all sides of equal length and all interior angles of equal measure. So that's not new. We've talked about what it means to be regular before. Alright, with this box, it's pointing to the center of the regular polygon. This center, it is equidistant from the vertices. So if I start at this center and I go draw a line from there to there or from there to there, it's all the same. The distance from the center of the regular polygon to each vertices, to each vertex is the same. Okay, remember I said what I called something else in a little bit. Look, this is just pointing to the altitude of that same triangle. Same picture we had up here. Same picture we had here, but now they're going to call it something else. This piece right here, we now call it the apothem. A-P-O-T-H-E-M. It's very similar to the radius of a circle. It's how far is it from the center of that polygon to the side of the polygon in a perpendicular line. So the apothem is the distance from the center to a side. That's what an apothem is. Again, think of it as nothing more, nothing different than the altitude of this triangle. Alright, something else we got to put in here. So a central angle, notice this one's pointing to this angle right here. This is called a central angle of a regular polygon. It has its vertex at the center. There's the vertex of the angle. It's the center of the polygon. And its sides pass through 2 consecutive vertices. Right there and right there. It passes through both of these vertices. This next part's important. Each central angle measure of a regular n-gon is 360 divided by n. So what does that mean? Finish writing that down and I'll scroll back up to my bigger picture. This is important. Each central angle measure of a regular n-gon is 360 divided by n. So let me come back to my picture. So how many sides does this shape have? It's got 6 sides, which means I have 6 central angles. I have this one, this one, this one, this one, this one, and this one. Now if I had done a prettier job, notice what does that make? It makes a circle. And there's 360 degrees in a circle. So to figure out what each one of these central angles is, there's 6 sides. So I do 360 divided by 6, which means each one of these central angles must be 60 degrees. And that'll help me later because I know this big angle is 60 degrees, and now I know this little one has to be 30. And again, we'll do more of that later. So the formula you need to know, and it is on your formula chart, the area of a regular polygon with apothem A and perimeter P is 1/2 times the apothem times the perimeter of your polygon. Alright, examples on the back. This one, pretty straightforward. It says find the area of this regular polygon. I started with the formula. Area equals 1/2 times the apothem times the perimeter. it told me everything I needed to know. It told me what the apothem was. There it is. It's 8. So all I did was plug in 1/2 times the apothem, which is 8. If this side is 6, there's 9 sides. So 6 times 9 is 54. So the perimeter is 54. Put that onto the calculator, you get 216 units squared. All right, this one, a few different ways to do this one. So if I can cover this up a little bit. It says find the area of this regular polygon. Well, I know this is 22, it tells me. I know this is 22, it tells me. So I can do special right triangle stuff, or I can just Pythagorean theorem it. If it's 22 all the way across, it tells me, then halfway has to be 11. So this piece has to be 11. And then I can just do Pythagorean theorem, square root of 22 squared minus 11 squared, so that's got to be roughly 19.1. So then my formula, area is equal to 1/2 times the apothem times the perimeter. 1/2, the apothem we figured out to be 19.1. Perimeter is 132. Put it onto the calculator, 1260.6 units squared. Right, find the perimeter of a regular polygon to the nearest tenth of a meter if the apothem is 10 and the area is 302. So I just plug in what I know. There's my formula. I plug in what it tells me. It tells me the area is 302 meters squared equals 1/2 times the apothem times the perimeter. Solve for P, and you get P is equal to 60.4. This one, it doesn't even ask you a question, so we're going to skip it. It's given a pentagon with each side 10 inches and the area, yeah, given that, what? I don't know. All right, again, I'm not expecting you guys to be experts on apothems and regular polygons, but you should be familiar with it by next time I see you. So now we're going on to circles. Formula for circumference, 2 pi r. It's on your formula chart. You don't have to memorize it. Formula for area of a circle, pi r squared. Again, you don't have to memorize this one either. So now let's do some problems. Find the area of a circle with a diameter of 22 inches. So area is equal to pi r squared. I plug in area equals pi. Well, if the diameter is 22, then the radius, the r, has to be 11. So I do 11 squared. 11 times 11 is 121. So my answer is 121 pi inches squared. I'm not going to multiply it by the pi. I'm going to leave the pi as part of the answer. 121 pi. Okay. Find the radius of a circle with an area of 40 pi square meters. Again, start with the formula. A equals pi r squared. Now plug in what I know. It tells me that the area is 40 pi, and I'm trying to find the radius. So I have 40 pi equals pi r squared. Divide both sides by pi, and I get 40 r squared. If I square root both sides, I get the square root of 40 equals r. I can rewrite the square root of 40 as root 4 times root 10. So r equals 2 times root 10. Last one. So this is find the area of a circle with a circumference of 55 pi. So circumference is equal to 2 pi r, which means 55 pi must be equal to 2 pi r. Divide both sides by pi, and I get 55 is equal to 2 times r. Divide both sides by 2, and I get r equals 27.5. So I know what the radius is. Now again, I'm trying to find the area. Area equals pi r squared. So pi times 27.5 squared, because 27.5 is the radius. And I get 756.25 pi feet squared. That's it.